Welcome once again. Last time we have seen the Picard's method to find out the solution of differential equation. Now today we are going to see the next method, that is Euler's method, to find the solution of the equation. So the Euler's method, for that the equation will be y dash equals to f of xy. So that is the basic equation that we are finding out the solution, with the condition that y of x0 is equals to y0, and we want to find out the solution of this. So when we find out the solution here also, when you want to find out xi is nothing but x0 plus ih, where h is the common difference. Means when you want to have x1 is nothing but x0 plus h, x2 will be x0 plus 2h, and so on. So this type of information is available. Now here, when you want to find out the first approximation is given by, let us say we call it y1. y1 is nothing but y0 plus h times f of x0 y0. So x0 is the and y0, both the information are available. H is the common difference. Similarly, when you want to go for the next iteration, second approximation will be y2, which is nothing but y1 plus h times f of x1 y1. So in general, we can say that when you want to find out yi plus 1, then yi plus 1 is nothing but yi plus h times f of xi comma yi. So this is how we have to find out. So this is called Euler's approximation, and by this method we can find out the solution. Now let us try to consider this by means of an example. So example goes like this. That example says that solve the differential equation dy by dx is equals to x minus y square. Given condition is that y of 0 is 1, and you want to find out the value of y at x equal to 0.1, and number of steps is given to you. Number of steps is 5. So now let us go to the solution part. So in solution part, of course we need h first of all. So for h we have the value you want to find out at 0.1, that is x minus x0 divided by the number of steps. So x here we have to find out at 0.1, x0 which is given to you as 0, number of steps minus 0 by 5, that gives you 0.02, x0 is available as 0, y0 is available as 1 in the function f of x comma y, which is nothing but x minus y square. So first instance we want to find out y1. So when you write y1, it is nothing but y0 plus h times f of x0 y0. So when you put the value y0 is 1, it is 1 plus h, you got is 0.02, f of x0 y0, means it is f of x0 is 0, y0 is 1, means I have to put 0 and 1 in this function f of xy, x minus y square. And when I put that value, what I get is 1 plus 0.02 into minus 1, and finally we get 0.98 is the answer of y1. We will find out y2. So for y2 I have to go for the formula again, y1 plus h times f of x1 y1. So that is same as y1 we have got as 0.98. H is fixed now 0.02, and it is f of, now it is x1. So when you find out y1, you also find out x1, that x1 is nothing but x0 plus h, and x0 plus h means 0 plus 0.2. So x1 will be 0.02. So this value we will put here. So h at 0.02 comma y1, which is 0.9. And finally, when you put the formula, it is 0.98 plus 0.02, and when you calculate this, you get this as minus 0.9404, and ultimately on simplification it gives you 0.961. Similarly, we go for third iteration, y3. y3 is again y2 plus h times f of x2 comma y2. y2 we have got is 0.9612, h which is fixed 0.02, x2 we know that now it is plus 2h, so it is 0.04. So f of 0.04 and 0.9612. Finally, on simplification, we get y3 as 0.9435. Next, we will find out y4. y4 is nothing but y3 plus h f of x3 comma y3, that is equals to y3 is 0.9435 plus h 0.02 into f of, now what is x3? Yes, it is 0.06. So when you put this value, it is 0.06 comma 0.935, and on simplification it gives you the value 0.9269. Similarly, we can calculate y5 also. So when you calculate y5, it is as first example, I will do all the steps into h of f x4 y4. So it is 0.9269, h 0.02 into f of, what is x4 now? It is 0.08 and 0.9269. Finally, simplification gives you 0.9133. So this is the required answer, that 0.9133. So we can say that at x equal to 0.1, y will be 0.913. So similarly, you can do some more examples. Let me give you one example for exercise. Here, the example goes like this: that solve the equation dy by dx is equals to x minus y divided by 2. Interval is 0 to 3. Condition given is y of 0 equal to 1. Okay. Now when you want to find out the answer, h you have to go for, so step size is given here in this case. Step size h equal to 0.25. The question is out y at 1. So what is y at 1? That we have to find out. Step size is this. So how many steps will be there? Okay, and try to do the example. So number of steps will be 4. And when you find out the answer, let me tell you the answer also. When you find out y at 1, that y at 1 should be 0.8195. Please check the answer, that whether you are going to get it or not. Thank you. Next time again we will be doing the next method, that is modified Euler's method.